Hello and welcome to the Daily Space for today, August 2nd, 2018. I am today's host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a couple of kind of in-depth and exciting stories. At least I thought so. In our first story, I have a tale of a planet that, not a planet, of a star that didn't quite go boom, but kind of went boom back in the late 1800s. This particular star, Eta Carina, is actually a binary pair of stars. In the late 1800s, there was a flare event that for a period of time made Eta Carina the second brightest object in the entire sky, even though previously it had just been a run-of-the-mill system that was bright, that was noticeable enough to be one of the primary stars in the constellation Carina, but certainly was nowhere near the brightest. Well, once astronomers began turning telescopes on this particular region in the Carina star-forming nebula, they were able to make out this weird hourglass-shaped nebula surrounding the location of Eta Carina. This weird hourglass-shaped nebula is referred to as the homunculus, and trying to understand its origins, its shape, has been one of those things that astronomers have been trying to do ever since the star first decided to blaze its way into our sky. Now, Eta Carina is about 7,500 light years away from the Earth. It's 100 times the mass of the Sun, and remarkably enough, it's 5 million times brighter than our Sun. Now, when the homunculus was formed, it was formed with more than 10 solar masses worth of material. So there was a giant burp of some sort that gave off a massive amount of material, gave off a massive amount of light, and this is often referred to as a failed supernova. But after 7 years of detailed observations, it looks like the story might even be more interesting than that. A group of astronomers led by Nathan Smith of the University of Arizona and Armin Rust of the Space Telescope Science Institute have been following this object, and more importantly, following light echoes of this object in detail for 7 years. And as they follow along in detail, what they've been able to see is the pulse of light that was given off in the late 1800s slowly moving through the space around Eta Carina. In this series of images taken by the Hubble Space Telescope in 2003, 10, and 11, you can see a lack of, bright stuff, an increase in brightening of stuff, and then here you have the maximum brightening of stuff. What is occurring is photons that were given off during that burst of brightness in the late 1800s are continuing to move through space in a shell. As the shell of light moves, it periodically is able to illuminate, the interstellar media, that gas and dust that exists between stars. Here we see the shell of light beginning to illuminate this material and then continuing to brighten the material in 2011. By following this moving light echo, by following the movement of the material around Eta Carina, astronomers have been able to piece together that the speed of the material that was given off is consistent with that of a supernova, the kind of supernova that leaves no stars behind at all. But the light itself in this system is consistent when you look at it across X-rays and other high-energy colors of light that can pass through that homunculus nebula. The light that we see is actually consistent with there being a present-day binary system of one star, Eta Carina b, that is significantly larger than the other star, Eta Carina a. Eta Carina a is the larger star, Eta Carina b is the smaller star. What is now being concluded as more and more evidence comes in is that the Eta Carina system isn't just a failed supernova. It isn't just a present-day binary star, but rather this is a remarkable system where just over 100 years ago, there was a merger of two stars. This appears to have previously been a system with three different stars, two of which have merged together to form the larger star in this new binary system. It was during that merger event that there is this massive outflow of material that formed the Homunculus Nebula, that there is this amazing flash of light that was consistent with a supernova, but not actually tied to a supernova, and that all of the light in the present-day light echo that we're seeing was emitted. This is an amazing situation where, by using a variety of telescopes spread across the surface of the planet and orbiting over our world, scientists were able to piece together new clues to an old mystery. And by using these new clues, these light echoes that have now moved far away from Eta Carina, by looking at these light echoes in concert with looking at all of the other observations that have been made, we were able to figure out this just might be a case of stellar mergers that will indeed lead to an actual supernova in the not too distant future. It is thought that the larger of the two stars in this binary system just could go supernova, well, no later than 50 million years from now, and quite possibly significantly sooner. Astronomers observing this star are seeing it undergo the variable behavior that is consistent with an object gearing up to, well, go boom. So this could be that next great supernova, and it might not occur while we're alive, but it does give us a place to look for the next 50 million years. Now, moving out to look at worlds beyond our own solar system, we have another tale of exoplanet discovery. In this case, a group of astronomers led out of Cambridge University have been doing models to try and understand exactly what goes in to forming worlds capable of supporting life. They've come to the conclusion that you need a pair of different things to exist. One of these is you need a star that produces sufficient ultraviolet light to drive early chemical reactions on the surface of any orbiting worlds. And this UV light interacting with local chemicals will produce the early building blocks that lead to the kind of life we see here on Earth. Remarkably, one of those early building blocks is molecules involving cyanide, which is deadly to modern life, but appears to have been the thing that was needed to get life started. Now, you need to have some ultraviolet light, but not too much ultraviolet light. Zooming in on this diagram, you can see that there is this purple region which is considered the habitable zone. These are the places where you can end up with water existing on the surface of a world at that wonderful triple point where it can exist both as a fluid, as a water vapor, and also as an ice. You also have regions where, shown here in red, you have enough ultraviolet light to drive those early chemical reactions. Now, in this region referred to as the abiogenesis zone, We unfortunately don't have enough ultraviolet light. So, if you're going to go looking for life, the ideal places to go are these systems that combine both sufficient ultraviolet light and sufficient, uh, water, sufficient temperatures to drive the water. So, here is the region you need to be looking. Um, Now, going beyond looking for life, we are constantly trying to understand the worlds within our own solar system. And New Horizons is about to give us a new view of a particularly weird Kuiper Belt object or objects in the outer solar system. As you may have heard, on January 1st, New Year's Day 2018, the New Horizons mission is going to do a flyby of an object that has been nicknamed Ultima Thule. Now, it's unclear if the IAU will adopt this as the actual nomenclature, but today's actual nomenclature is MU69, which isn't entirely exciting, so we're going to go with its nickname, Ultima Thule. Now, in preparation to observe this object up close with New Horizons cameras, astronomers here on Earth are working to perfect their understanding of this particular object's orbit. In order to do this, they've been observing this object over and over with all the telescopes they can, whether it be the Hubble Space Telescope or multimeter telescopes here on the surface of the planet. Unfortunately, there's always some error in these measurements. And one of the best ways that we found to get at the details we really need to know for a flyby, are there moons? Is this a object of unusual geometry? To get at all of these details, the best thing we can do is wait for the object to pass in front of a background star and make very precise timings of when that background star appears to dim and then brighten as Ultimate Thule passes in front of it. By looking at these dimming and rebrightening events from multiple places on the surface of the Earth, we can get multiple lines of sight that give us very precise measurements of the shape of the object and will highlight, or I guess will shadow, any of the moons that may happen to be orbiting this object. This kind of what we call an occultation event was last observed in on July 17th, 2017, from astronomers who aligned themselves through Patagonia and Argentina to catch an event. These early observations clued us in that Ultima Thule appears to perhaps be a contact binary, two separate objects that are just touching one another. Or perhaps alternatively and less excitingly, it's just an oblong object. Which of these two circumstances just might be the true circumstance? Astronomers are hoping to learn on August 4th, just a couple of days from now, when observers deploy to Senegal, West Africa, and to Colombia in South America, or I guess Central America, rather. And from observatories, from telescopes set up in Senegal and Colombia, they will be looking to see a background star fade away, rebrighten, and provide them the information needed to get a good shape model for this object and to see whether or not there are any moons that the New Horizons mission will need to worry about. I, for one, am greatly looking forward to the results of this set of observations. Now, these are our main stories for today, and I am now ready to take your questions. Before I do that, I'd like to remind you that the Daily Space is a production of CosmoQuest. We invite you to visit cosmoquest.org and help us map out our solar system and our own planet Earth. We have scientists particularly requesting data on Mars and Mercury right now, so please go ahead and, help us map out the surface features that decorate these two rust-colored worlds. CosmoQuest is brought to you out of the Astronomical Society of the Pacific, working in collaboration with a number of other institutions. Here on Twitch, you'll see not just me and other members of our ASP staff, including Dr. Andreas Plazas and Joe Myers, but you'll also meet Dr. Matt, who brings you Astro 101 on Wednesdays and Fridays. You'll see Annie Wilson, who works on planetarium content and brings you Sunday Science. Working together, we are all here to help support all your Astronomical Society needs. So give us a follow, find out when we go live, and we are sustained through your subscriptions. Every bit really matters. So thanks for coming, and now for the questions. Let me switch views and bring the questions a little closer to my line of sight. So I see Henny's Vorverb asking, could they get a better read on its location through Parallax? So Parallax is the way that we're able to measure the distance to fairly nearby objects by looking at how they appear to move as our vantage point changes. You can actually play with Parallax by holding your thumb out at arm's length and closing one eye and blocking out some distant object with your thumb. Now, if you switch which eyeball is open, you'll see your thumb jump as compared to that background object that you just blocked out. We use the theory of like triangles and our understanding of the distance between the two things that, moved our perspective. So often in astronomy, we use the orbital diameter of the Earth's orbit around the sun. As the Earth jumps from one side of the sun to the other side of the sun, we can see nearby objects, stars in particular, appear to move against background quasars and other objects that don't appear to move as our own Earth orbits the sun. Now, where we're dealing with a Kuiper belt object that is orbiting the sun, parallax becomes tricky because our own motion and its motion all have to be factored together. In trying to get a better handle on its exact motion through the sky, our best bet is to observe it over and over and over again and make these occultation measurements to narrow down its profile. And by combining information on how it appears to move against background stars while taking into account our own motion, we can begin to decouple its orbit, and then we can really hone in on exactly where it is on a given, second in time by looking to see how it appears to block out background stars. So it's a whole lot of complicated math. It's a whole lot of complicated motions. But the amazing thing about science is if we work through all of the often tedious equations, and if we make all the needed observations, science lets us understand these things. In this case, it's not entirely straightforward, but it's enough. And we know that on January 1, our little spacecraft that might fit in your walk-in closet is going to be flying past a new object in the outer solar system. So I'm going to look and see what other questions we may have. Okay, more. Automod got you on that one. I'm so sorry about that. So it's MU69 is the name of this object. Autocorrect is going to do bad things to that, I suspect. So Pluto is a fairly large object. Because Pluto is large, we were able to get images of it on the approach. We will get images on the approach with this object, but they're not going to be very exciting. I'm not sure when they'll be released. Stay tuned through December. I know it's going to be a big deal on January 1st, but because, as I said, this is quite a tiny object, it's unclear exactly how good it's going to look in the images prior to encounter. Here we're dealing with a double whammy of New Horizons itself isn't that large a telescope. So when you have a small object and you have a small telescope, you have to get pretty close before that small object looks like anything other than a blob in the sky. So that's where we are for MU69. Oh, thank you for the bits so much, Fenring. Let me look over at Streamlabs. So, and thank you, thank you, Fenmill, for the bits, and thank you, Fenring, for gifting a sub to Hanny. And thank you, Fenmill, for the resubscribe. You're up to 8 months now. That's amazing. This is a good day. Thank you all for all of your support. That really does make this show possible. Can we light up the chat with all those rockets firing in celebration? Thank you so much for supporting our show. Yes, all of the rockets firing. Okay, I'm now kind of speechless and happy. So do we have any more science questions out there? So Hania is asking, so they are assuming that life formed on the surface in pools and not near hydrothermal vents. So Hanny's Vorverb, it's not so much a question of where did life evolve as where did the chemicals that life needs first evolve. So a planet has to go through a lot of different stages before life can really exist on it. It needs to solidify enough that it has a surface, or at least has segregated the water from the molten land. Once you have this separation of water and land, and Susie, that was the most spectacular emoji fail ever. Once you have a semi-solid planet, then you start having interactions between all of the different atoms on the world, forming different molecules. And those molecules eventually create the building blocks for life. What this particular paper is saying is that those necessary building blocks required ultraviolet light to form. Now, the next step is where did those molecules go, and where did those molecules that went somewhere, what actually ended up forming life? We don't know the wheres of life forming. All we're saying with this particular paper is the place to look for life like what we have here on Earth is worlds that were blasted with ultraviolet radiation. I like your logic on the dogs, Big J. So Fenring is asking, is there a way to know what were the initial types of stars that led to failed supernova and what actually happened? We're working on that. There's only been a handful of failed supernova observed so far. These are often objects where we think we saw a supernova, and then, oh shoot, no, it actually went off much later in the future. Um, and these appear to be supermassive blue stars in general. Uh, so beyond that, stay tuned. Stay tuned. We're still working to learn these things. So Kay Moore is saying, what else do we know for sure about Mu 69? Or are we just holding our breath on the flyby to learn more? So we do know a fair amount. I just have to look at my screen to tell you what it is. Um, so, oh man, sorry. I started looking at the notes for the occultation instead of the notes for the object itself. So MU69 is an object that was first identified in 2014. It was found with the Hubble Space Telescope. As some of you may remember, here at CosmoQuest, we were actually part of the team to look for objects in the Kuiper Belt that New Horizons would be able to encounter. While we did discover some objects, they all had the wrong kind of orbit. And in the end, the observing team wasn't able to find any future observing candidates using ground-based telescopes, and they had to use the Hubble Space Telescope. In 2014, using the Hubble, they found MU69. This particular object was selected in August 2015 to be the encounter target. According to NASA, it has the nickname Ultima Thule. Official names come from the IAU, so there is a chance that an official name will come out in the next month during the International Astronomical Union that is just 2 weeks away from really getting started. We will be bringing you live coverage from the International Astronomical Union meeting, so please, please, if you haven't followed yet, follow now so that you get all of that coverage. Now, in terms of what we know about this object, well, it's tiny. By tiny, I mean that it appears to be 25 to 45 kilometers in diameter. It is either made of two objects that are about 22 kilometers across, or of one object that is about 45 kilometers across. We just don't know. It's not the most reflective thing. This is why it was hard to find. It's at a distance of 42 to 46 astronomical units away from the Earth. So this is another one of those situations where we're going to be waiting hours for the data to reach us after the encounter occurs. It's all a bit frustrating to have to wait for things to occur with these kinds of events. So we don't know a lot. Hopefully we will learn more thanks to this upcoming occultation that will be observed on August 4th. And then we just stay tuned. Yeah, that's what we've got. So it's basically just your classic cold, orbiting mostly in the plane of the solar system, on a fairly eccentric, this means oval-shaped, ellipse-shaped orbit. Yeah, we can't wait to see it and see how different its surface is from what we've already seen with Pluto and Charon. So looking to see if there are any other questions. Fedmel, that is one of my favorite quotes and has led to more things being named George in my life than I care to admit to. Yes, Eddie emotes can totally be a thing when we get partnered. Um, I don't think 23 cubed is actually 69. Oh, you mean 23 times 3. I misread it. Yes, 23 times 3 totally would work. Um, if there aren't any other questions, I'm going to be reminding you that tonight I will be bringing you um, the learning space stream. We are going to be doing an interview tonight with the woman behind Astroquizzical. Dr. Julian Scudder is going to be with us, and that show will be starting at 9 Eastern, 6 Pacific. That's 11 a.m. tomorrow for all of you who are in the same time zone as Sydney. So come back in a few hours and we will have more ways for you to learn and do science. If you've got some spare time, if you've got some spare screen real estate, please hop on over to CosmoQuest.org and help us do science. We have a particular need right now for Mars and Mercury data. Um, I am your host, Dr. Pamela Gay, and this is a production out of the Astronomical Society of the Pacific, working in collaboration with the Planetary Science Institute and Youngstown State University. Please give us a follow, and we are sustained through all of your subscriptions, and every bit really matters. Thank you so much to all of you who have helped us out today. Special thanks for Fenrig, to Fenmill, and Hanny. Go ahead and enjoy that subscription. And I will hopefully see many of you tonight. And as Guido points out, everything will be available for watching tomorrow for those of you in the European time zones. So thank you, and wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember to get out and look up, and particularly look at Mars. It's near and bright right now. Bye-bye.